Project 102 is batteries in series. When I turn on the slide switch, both the red and green LEDs light up, and the batteries are connected in series in this circuit. If I was to remove one battery, or if I disconnected one of the battery holders, the LEDs will go out because they need both battery holders connected in order to stay on in this particular circuit. But using the batteries in series creates more voltage so that the LEDs light up at full brightness. Project 103 is batteries in parallel. Now, you're supposed to put weaker batteries in the left holder and strong batteries in the right holder. And then you would turn on the switch and the lamp will become bright as the strong batteries take over and supply current to it. Batteries would be used in parallel when the voltage is high enough, but you need more current than one group of batteries can supply. Like each battery acting as a storage tank that supplies water. With two tanks in parallel, you get more water, which resembles the current, but the pressure, which resembles the voltage, stays the same. Project 104 is Spacey Fan. Now, when I put all the batteries in the holder and shine light on the photoresistor, the sound from the Spacey integrated circuit changes. It can be heard through the whistle chip. The fan spins, and what's interesting is that the fan will spin if there's light on the photoresistor or if the press switch is pushed. But you have to have both light on the photoresistor and the press switch held down for the fan to rotate at full speed. But shining light on the photoresistor changes the sound effect from the IC. Pretty cool. Project 105 is two-transistor light alarm. This circuit uses both the PNP and NPN transistors. When I remove one or both ends of the red jumper wire, the lamp goes on. When I reconnect it, the lamp goes off. You could have a longer wire and run it across a doorway, so if an intruder comes in, the light will come on when he or she removes the wire. Project 106 is light-controlled alarm. When I connect both batteries, you will hear a buzzing sound, but when I shine light on the photoresistor, the sound gets louder. If I was to cover the photoresistor completely, the sound will stop. Again, this is a light-controlled alarm. Some alarm systems may use this to detect light, so if an intruder turned on a light or accidentally hit a sensor with the beam of a flashlight, let's say, the alarm will go off. And you could possibly use this as like an alarm clock to wake you up as soon as the sun comes up. I don't know how practical it will be, but that could be another possible application for a circuit like this. Project 107 is automatic street lamp. Although the diagram shows the press switch being used, I'm going to use the slide switch because it's easier since I'm holding the camera with one hand. I'm going to have the RV lever all the way toward me, and when I turn on the slide switch, nothing happens. I'm going to cover the photoresistor, and the lamp comes on. When I shine light on the photoresistor, the lamp turns off. If I move the RV switch away from me, then it may be harder to shut the lamp off. As you can see, I have to hold the main light directly over. Even then, it doesn't really turn off. But the principle of this project is like that of street lamps and other outdoor lights that come on at nighttime or when needed for safety, such as in bad weather. And the photoresistor works opposite of how it does in most projects in snap circuits, in that now when light shines on the photoresistor, resistance increases, and when light cannot reach the photoresistor, or if it is dark in the area it's at, resistance will decrease and the lamp will come on. Project 108 is voice-controlled rays of light. When I turn on the slide switch, the LEDs come on. But if I was to talk loudly into the microphone, which I'm going to do now, this might be loud. Hello? How are you doing? You'll see that the LEDs flicker and get brighter. Actually, while I'm talking now, you can see them flickering because the microphone is so close to me. I'll do it again. Goodbye. Have a nice day. You could also place the circuit near a radio or television set or stereo, and then the LEDs will get brighter. You'll see that the red LED is brighter than the green LED because it requires less energy. Project 109 is blowing off the electric light. For this project, you would blow into the microphone, or the lamp will turn off, and I'm going to do that right now. You'll see it goes out, and then comes back on again. I don't know if I caught it the first time. The capacitor, I think, allows the lamp to stay off for a little bit before coming back on. You can pretend this is an electronic version of a magic candle that reignites after you blow it out. Talking loudly into the microphone will adjust the brightness of the lamp, but I don't think it will actually make it go out. Project 110 is adjustable tone generator. When I turn on the slide switch, you will hear a high-pitched sound. The RV lever is all the way to the left. I'm going to slowly move it to the right. And the pitch goes even higher. This is an example of an oscillator circuit in which changing the values of resistors or capacitors, which in this case would be moving the RV lever, varies the output tone or pitch. You change the frequency of the circuit. Project 111 is photosensitive electronic organ. I replaced the R4 resistor with the photoresistor, and I'm going to shine a light over it, and the sound changes. Now you could pretend you're playing an organ by using your finger and moving it over the photoresistor to imitate playing the real instrument. And then you could also move the lever on the RV to produce an even greater combination of sounds and other tones. The LED will flash at the same frequency as the sound. You can watch it. For this variant, electronic Cicada, I placed the C1 capacitor over the whistle chip, and I'm going to turn on the slide switch. The RV lever is all the way to the left, and the circuit may sound like a cicada. You can adjust the RV if necessary. Do the sounds that you hear remind you of those of a natural cicada? To me, they don't really seem to do so, but they could sound like another insect. It's possible to pick resistors and capacitors that make the pitch of a sound so high that humans cannot hear it. But, well, a human can only hear a sound up to 20,000 cycles per second, or hertz. A parakeet can hear tones up to 50,000 hertz, or 50 kilohertz. Projects 113 through 117 are light and sounds. For these projects, you will hear different alarm tones that are accompanied by an incandescent lamp that will come on when the alarm sounds. The first alarm tone is a police car siren. You just have a 3-snap wire connected between points V and W as shown in the manual. And then, if you place a 3-snap wire between points X and Y, here, you have a machine gun sound. And the incandescent lamp blinks since the sound from the alarm IC is controlling the current through it. If I put the 3-snap wire between points T and U, it now sounds like a fire engine. When I remove the connection between points T and U and place a 2-snap wire between points U and Z, you have an ambulance siren or European siren. Now, they say when you, for the last variant, when you remove the connection between points U and Z and place the C5 capacitor, the sound will change every few seconds. But you just hear a machine gun sound and the incandescent lamp flashes. I'm not sure why. They say it goes between points X and Y. But anyway, that's light and sounds. Project 118 is motor speed detector. When you turn on the slide switch, nothing happens. But when I turn the motor clockwise, without putting the fan on it, watch the LED. It flashes. This is why this is called motor speed detector, because the LED will light up when the motor is spinning clockwise. Now, if you turn it counterclockwise, nothing will happen because current can only flow through the LED in one direction. And turning the motor counterclockwise makes the current flow in the opposite direction than when it was being turned clockwise. You could play a game to see with other people, see who can make the brightest flash. And what you could do, though, is rotate the motor, and now the LED only flashes if the motor is being spun counterclockwise, and not at all when it's spun clockwise, due to the direction in which the current is flowing now. Project 119 is old-style typewriter. Turn on the slide switch, nothing happens. Now listen carefully as I slowly turn the motor with my fingers. You hear a sound that might resemble that of an old-style typewriter when you push the keys. It's an electronic typewriter, except you can't actually write with it. But in this project, the speaker will sound regardless of the direction in which you spin the motor, because current can flow through the speaker both ways. And this may give a good idea of how in power plants, steam is used to power large motors to produce electricity for your town or city. But the steam is generated through some sort of energy method like coal, oil, gas, nuclear, or wind power. Project 120 is Space War sounds. I'm going to leave the slide switch in the off position and push the press switch. Listen. When I hold the press switch down, you hear Space War sounds. And they change every time you push the press switch. Now I'm going to turn on the slide switch, and one sound will be played continuously. Then when I turn the slide switch off and on again, it's a different sound, but it will play until you turn the switch off, or until you push the press switch. That will also change the sound. I'm sorry it's not very loud for some reason. The Spacey IC has logic built into its circuitry that allows it to switch between many different sounds, which is very interesting. For Project 121, Spacey sounds controlled by light, I replaced the slide switch with the photoresistor, and I'm going to shine a light on it, and a sound will play continuously. If I remove the light from the photoresistor, the sound stops. Then, when I shine the light back on, a different sound is played. And you can wave your hand over the photoresistor, hear all the different sounds, although I'm not going to do that. You can push the press switch down, and now 2 Space War sounds will be played. And if you hold the press switch down, the sound repeats, and then keep pushing it to hear different sounds. I can only do a verbal demonstration for Project 122, Space War Radio. But for this project, you'll need an AM radio, and you would turn it on and tune it on a setting where no stations are heard, like I guess on either end of the AM band. And then you would turn on the slide switch of the circuit and use the variable capacitor to tune to a place where you may eventually hear Space War sounds coming from the radio itself, because this circuit is converting sounds from the Space War IC into radio waves to be picked up by another receiver, which would be this radio here. And for some reason it doesn't work for me, but you're essentially performing the experiment that Marconi, who first developed radio transmission, it took him a lifetime to invent it. And we now take radio transmission for granted. But before that, news could only be spread by words, such as in the newspaper, or by our mouths.